In the silent, classified archives of global military intelligence, an object designated 3I/Atlas is being tracked not with telescopes, but with instruments designed to detect gravitational distortions in the fabric of space-time. The data they are receiving suggests this interstellar visitor is not just a rock, but a broadcast. A message written in the language of gravity itself. What if the silence of space is not an absence of life, but a testament to a communication method so advanced, we mistook it for the quiet of the void? Today, we journey into the heart of a global military secret. We will examine the impossible signals emanating from 3I/Atlas and reveal why this discovery has triggered the highest levels of national security. To understand what they found and why they are so afraid, subscribe and join our expedition into the classified unknown. Prepare yourselves. We begin. Our story does not begin on a lonely mountaintop, under a dome open to the starlight. It does not begin with the patient gaze of an astronomer. It begins in the cold, sterile, and windowless heart of Cheyenne Mountain, deep within the command structure of the United States Space Force. Here, a program exists that has never appeared in any public budget, a constellation of assets whose true purpose is one of the most closely guarded secrets of the modern world. The program is codenamed Aegis Array. It is not an instrument of sight, but of feeling. Its purpose is to listen to the vibrations of the universe itself. The array is a network of satellites, but they are not the elegant, winged surveyors we see in NASA animations. They are dense, cryogenically cooled spheres of exotic alloys and superconducting sensors placed in carefully calculated orbits that form a vast, invisible net around the solar system. Their official, though classified, justification is strategic defense. They are designed to detect the theoretical gravitational signatures of cloaked enemy spacecraft or the space-time distortions of experimental propulsion systems. They are the ultimate tripwire, but their sensitivity extends far beyond the crude technologies of humankind. The Aegis Array is capable of detecting high-frequency gravitational waves, ripples in the cosmic fabric so faint, so subtle, that our public instruments like LIGO or Virgo would be deaf to them. For years, the array has listened, recording the gentle, predictable hum of the cosmos. It has felt the distant collisions of black holes, the death rattles of neutron stars, the violent, chaotic, but fundamentally natural sounds of the universe. It has provided a baseline, a constant stream of data that defined the normal, rhythmic breathing of space-time. For years, the data was predictable. For years, the universe was quiet. And then, it wasn't. The first hint of what was coming arrived not as a tremor, but as a whisper, thousands of miles away from the silent command centers of the Space Force. The discovery of the object itself was entirely conventional, almost mundane. On a clear night in Hawaii, the Panoramic Survey Telescope and Rapid Response System, or PAN-STARRS, was doing what it always does, methodically scanning the sky, taking pictures of the same patches of darkness, night after night. Its software then compares these images, searching for tiny points of light that have moved. It is a tireless, automated search for the things that wander through our solar system, the asteroids and comets that are our silent neighbors. On one of these nights, the software flagged a new object. It was impossibly faint, a barely perceptible smudge of light moving at a speed that defied the sun's gravity. Its trajectory was not a gentle, looping ellipse, but a sharp, clean hyperbola. This was the mathematical signature of an outsider, an object not bound to our star, but one that was merely passing through on a journey from some other sun, somewhere in the vast, cold darkness between the stars. It was given a formal designation, 3I/Atlas. The 3I stood for the third interstellar object ever confirmed. The astronomical community buzzed with a quiet excitement. The first Oumuamua had been a strange, cigar-shaped mystery. The second, Borisov, had been a more familiar, comet-like body. This third visitor offered another precious chance to study a piece of a different solar system, a fossil from a world we would never see. Telescopes around the world were pointed in its direction. Spectrographs tasted its faint, reflected light, trying to discern its chemical makeup. Preliminary findings suggested it was a fairly standard cometary body rich in ice and rock, perhaps a few kilometers across. A routine, if thrilling, chapter in astronomy was about to be written. For a few weeks, everything was normal. The object followed its predicted path. The data was clean. The universe was behaving exactly as the textbooks said it should. And then, deep within the Aegis Array network, an alarm no one had ever expected to see was triggered. The pivot back to the military sphere was not gradual, it was a schism, a violent branching of realities. While the public world of science was tracking a faint comet, the secret world of defense was confronting the impossible. In a data fusion center for the Aegis Array, an automated monitoring system flagged an event. It was not a loud, sudden spike, not the gravitational scream of a black hole merger that the system was designed to alert on. It was something far stranger, a persistent, coherent signal buried deep within the background noise of spacetime. The system's algorithms, designed to find patterns, had found one that defied all explanation. An analyst, likely a young Air Force officer with a PhD in physics, would have been the first to see it. Their initial reaction would have been dismissal. It had to be an error, a sensor malfunction on one of the satellites, a solar flare momentarily confusing the delicate instruments, a software bug in the correlation algorithm. They would have run every diagnostic in the book. They would have isolated each satellite in the array, checking its data stream individually. They would have cross-referenced the event with every known source of interference, from solar activity to terrestrial ground vibrations. But with each test, the terrifying truth would have solidified. The error was not in the instruments. The signal was real. When the array's data was focused, when the signals from multiple satellites were combined to create a single, high-resolution listening field, the source of the gravitational wave was pinpointed. It was not a distant galaxy. It was not a hidden object in the far reaches of our own solar system. It was emanating from the precise celestial coordinates of 3I/Atlas. This was, in no uncertain terms, impossible. A comet, a chunk of ice and rock, does not emit gravitational waves. It is a passive object, a victim of gravity, not a source of it in any active sense. To emit gravitational waves, an object must be undergoing extreme acceleration. It must be incredibly massive and compact, like two neutron stars spiraling into each other at nearly the speed of light. A comet simply tumbles through the void. For it to generate a gravitational wave would be like a falling leaf generating a sonic boom. But this was not just a single, inexplicable pulse. It was a structured, repeating signal. It was modulated. It had a complex waveform with nested frequencies, a carrier wave with information imprinted upon it. The difference was as profound as the difference between the random roar of a waterfall and the structured, deliberate patterns of human speech. Nature produces noise. It does not compose symphonies. The signal coming from 3I/Atlas was a symphony. It contained a level of order, of mathematical precision, that could not, under any known law of physics, be the product of a natural phenomenon. Within hours, the discovery triggered a cascade of protocols so secret that most of the military itself was unaware of their existence. The data was firewalled, encrypted, and transmitted up a chain of command that led directly to the highest levels of the Pentagon and the White House. This was no longer an astronomical curiosity. It was a first contact event of the most bewildering and frightening kind. And the first decision made in response was not one of revelation, but of concealment. A curtain of absolute impenetrable silence had to be brought down immediately. The mechanisms of this secrecy were swift and brutally efficient. in the public databases where astronomers from around the world shared their tracking data for 3i/Atlas, a subtle update was pushed. A new set of observations, likely fabricated from a classified observatory, were added. These observations showed the object behaving erratically. Then, a carefully worded bulletin was released through official astronomical channels. 3i/Atlas, it was announced, had likely undergone a fragmentation event. Perhaps, it was theorized, a pocket of volatile ices had been heated by the distant sun, causing the cometary nucleus to break apart, just as other comets sometimes do. The bulletin stated that the object had become a diffuse cloud of dust and gas, making any further meaningful observation of its trajectory or composition impossible. It was a plausible, even common, fate for a comet. It was a perfect cover story. The astronomical community expressed its collective disappointment. A few papers were published lamenting the lost opportunity, analyzing the final moments before the fragmentation, and then, as is the way of science, the world moved on. There were other stars to watch, other mysteries to solve. 3i/Atlas became a footnote, a cosmic visitor that broke apart before we could get a good look at it. But behind this wall of lies, the real work had just begun. All existing and future data pertaining to 3i/Atlas, from every military and intelligence gathering asset, was placed under a level of classification usually reserved for nuclear launch codes. The Aegis Array, its secret purpose now superseded by a mission of unimaginable importance, was tasked to focus its full, unblinking attention on the silent messenger that was still very much intact and was still broadcasting its impossible song as it sailed through the quiet depths of our solar system. The curtain had fallen. The public saw only darkness, a lost object, but for a handful of people on the planet, the world had been changed forever. They were now the sole audience for a broadcast that was not meant for human ears, a message written in a language of pure gravity, sent from an unknown intelligence for an unknown purpose. The silence that followed was not the silence of the void, it was the silence of a secret being kept. To understand the depth of that secret and the terror it induced, we must first understand the world that it shattered. We must rewind the clock before the impossible signal, before the silent visitor, and journey back to a time when our conception of the cosmos was defined by a single, overwhelming reality, an absolute and profound silence. For more than half a century we had been listening with all the ingenuity our species could muster. And the universe, in its infinite majesty, had answered us with nothing at all. This was the established reality. This was the calm before the storm. Our search for others began with an assumption so logical, so intuitive, that it became the unquestioned bedrock of an entire field of science. The assumption was that if another intelligence wanted to be heard across the gulf of interstellar space, it would use light. Specifically, it would use radio waves. The reasoning was simple and elegant. Radio waves are a form of electromagnetic radiation, and they travel at the ultimate cosmic speed limit. They are relatively cheap to produce in terms of energy, requiring only a transmitter and an antenna. They pass through the dust and gas that clouds much of the galaxy with little interference. It is the path of least resistance. Any civilization that develops even rudimentary technology will, inevitably, discover the electromagnetic spectrum. They will use it for their own planetary communications just as we did, to then turn that technology outward, to amplify it and beam a greeting to the stars, is a small and logical next step. It is the cosmic equivalent of learning to build a fire and then realizing you can use it to create smoke signals. We assumed that this was a universal technological milestone, the low-hanging fruit of galactic communication. And so, we began to listen for the crackle of another tribe's fire. The formal search began in 1960, a moment of profound technological optimism. A young radio astronomer named Frank Drake, working at the National Radio Astronomy Observatory in Green Bank, West Virginia, conducted the first modern SETI experiment. He called it Project Ozma. Its ambition was humble, its equipment almost laughably primitive by today's standards, but its spirit was monumental. Drake pointed an 85-foot radio telescope toward two nearby sun-like stars, Tau Ceti and Epsilon Eridani. They were cosmic neighbors, just over 10 light-years away. For 6 hours a day, for several months, the telescope listened. Drake tuned his receiver to a specific frequency, 1,420 megahertz. This was not a random choice. It is the frequency naturally emitted by neutral hydrogen atoms, the most common element in the universe. He reasoned that any advanced civilization would know of this fundamental cosmic channel. It was a universal signpost, a natural place to meet in the vast static of the radio dial. It was later dubbed the waterhole, a quiet place where all creatures might gather to drink. For those few months, a small group of scientists stared at a chart recorder, a pen scratching a wavy line on a roll of paper, hoping to see a spike, a pattern, a deliberate pulse that would stand out from the random hiss of the cosmos. They found nothing. Just the quiet, steady, and indifferent noise of the galaxy. Project Ozma ended in silence, but it had ignited a dream. The search had begun. For decades that followed, the search continued, growing in sophistication and scale. Telescopes grew larger, receivers became more sensitive, and computers allowed astronomers to listen to millions of channels at once. The dream of a simple, clear signal, however, remained elusive. And then, for 72 brief, electrifying seconds in the summer of 1977, we thought we had found it. At Ohio State University's Big Ear radio telescope, an astronomer named Jerry Eman was reviewing the computer printouts from the telescope's survey of the sky. The data was a long, monotonous string of single digits and letters representing the intensity of the signal at different frequencies. It was a mind-numbing task, looking for a needle in a haystack the size of the sky. But on one page, Eman saw something that made him stop, his heart pounding. In a column of otherwise random characters, there was a sequence that stood out like a beacon, 6EQJ5. It represented a signal that was not just strong, but impossibly strong, 30 times louder than the background noise of deep space. It was a narrow-band signal, exactly the kind of artificial transmission SETI researchers had predicted. Natural cosmic sources tend to broadcast over a wide range of frequencies, like a floodlight. An artificial signal would be focused, like a laser beam. This was a laser beam. The signal lasted for the full 72 seconds that the telescope was pointed at that patch of sky, and then, as the Earth rotated and the telescope moved on, it vanished. Eman was so stunned, so overwhelmed by the implications, that he circled the sequence on the printout and wrote a single word in the margin: wow. The wow signal became the most famous, most tantalizing, and most frustrating artifact in the history of SETI. It had all the hallmarks of a genuine extraterrestrial message. It came from a region of space where there were no planets or known satellites. It was at a frequency near the hydrogen line, just as Drake had theorized. It was powerful and unambiguous. In the weeks, months, and years that followed, every radio telescope that could be spared was pointed back at that same patch of sky in the constellation Sagittarius. They listened. They listened with more power, with more sensitivity than the Big Ear telescope ever had, and they heard nothing. The signal was gone. It never repeated. It was a single, cosmic shout in the dark, and we were not there to hear it whisper. Was it a genuine signal from another world, a broadcast we happened to cross for a fleeting moment? Was it some unknown and bizarre natural phenomenon? Or was it, as some skeptics later argued, a signal from Earth that had bounced off a piece of space debris and been reflected back into the telescope? We will never know. The wow signal was a ghost, a singular moment of hope that, in its refusal to ever return, only served to deepen the silence that came after. the silence became louder, more profound. With projects like the Allen Telescope Array, we were no longer just listening to a few stars at a time. We were conducting vast systematic surveys, sweeping the sky, sifting through an ocean of data. Yet the result was always the same: nothing. The quiet of the cosmos began to feel less like an absence of signal and more like a presence of unnerving, deafening silence. This accumulating silence gave birth to one of the most troubling questions in all of science: the Fermi paradox. Named after the physicist Enrico Fermi, who is said to have posed the question during a lunchtime conversation in 1950, it is a paradox of scale. The argument is simple. Our galaxy, the Milky Way, contains hundreds of billions of stars. We now know that most of those stars have planets. A significant fraction of those planets likely orbit within the habitable zone, the region where liquid water could exist. If even a tiny fraction of those planets developed life, and a tiny fraction of that life developed intelligence and technology, then the galaxy should be teeming with civilizations. The numbers are so vast that it seems a statistical inevitability, and the galaxy is old. It has existed for more than 13 billion years. There has been more than enough time for civilizations to arise, to spread across their solar systems, and to begin exploring the stars. Even with slow, conventional space travel, a single civilization could colonize the entire galaxy in a few million years, a mere blink of an eye in cosmic time. So, the question, the profound and haunting question, is this: where is everybody? If the galaxy should be full of life, if it should be a bustling metropolis of star-faring civilizations, why do we see no evidence of them? No probes, no megastructures, no radio signals, nothing. All we see, all we hear, is the vast, cold, empty quiet. The Fermi paradox turned the search for life on its head. The silence was no longer just a null result. It was a piece of data in itself. A terrifying piece of data that suggested something was deeply wrong with our assumptions. It was into this silent, empty-seeming cosmos that our first confirmed interstellar visitors arrived. They were not emissaries in starships. They were rocks. In 2017, the same Pan-STARRS telescope that would later find 3I/Atlas spotted the first one. It was designated 1I/Oumuamua, a Hawaiian name meaning scout from a distant past. And it was deeply strange. It was small, dark red, and tumbling through space in a chaotic way. From the way its brightness varied, astronomers inferred a bizarre shape. It was either a flat, pancake-like object or a long, thin, cigar-like one, 10 times longer than it was wide. Nothing like it had ever been seen in our solar system. Most puzzling of all was its trajectory. As it swung around the sun and headed back out into deep space, it accelerated. It sped up, pushed by a tiny, mysterious force other than the sun's gravity. For a comet, this would be normal. As the sun heats the ice, jets of gas erupt from the surface and act like tiny rocket thrusters. But Oumuamua had no visible jets. It had no cometary tail, no fuzzy coma of gas and dust. It was accelerating silently. This led to a flurry of scientific debate. Was it an object made of solid hydrogen or nitrogen, outgassing in a way that was invisible to our telescopes? Was it a new, unknown type of celestial body? A small minority of scientists, most notably the Harvard astronomer Avi Loeb, even dared to speculate that it could be an artifact, a piece of alien technology, a solar sail, thin and light, pushed by the pressure of sunlight itself. But for the vast majority of the scientific community, the conclusion was clear. Oumuamua was a natural object. A strange one, to be sure, a puzzle that challenged our models of planetary formation, but it was a natural object, because above all else, it was silent, it broadcasted nothing. It was a piece of cosmic driftwood, nothing more. If Oumuamua was the unsettling mystery, the second interstellar visitor was the comforting confirmation. 2 years later, in 2019, an amateur astronomer named Gennady Borisov discovered 2I/Borisov, and it was, in a word, normal. It looked like a comet. It behaved like a comet. As it neared the sun, it grew a bright, beautiful tail of dust and gas, just as any comet from our own Oort cloud would. Its chemical composition was familiar. It was a textbook example of what astronomers expected an interstellar comet to be. It was profoundly reassuring. It told us that the processes that formed our solar system were likely common throughout the galaxy. It suggested that Oumuamua was the exception, not the rule. Together, these two visitors, one bizarre and one familiar, established a critical baseline. They defined the accepted reality of what an interstellar object was. They were natural bodies forged in the fires of another star system, sent on a long journey through the void. They might be strange, they might be puzzling, but they were fundamentally just rocks and ice. They were quiet. They tumbled silently through space, subject only to the laws of gravity and light. This was the normal world of interstellar astronomy, a world of silent, natural messengers, a world that was about to be broken. This baseline of normalcy, this established reality built on a century of listening to silence and witnessing the passage of mute, natural objects, is what makes the discovery locked away in the servers of the Aegis array so profoundly terrifying. They were not seeing a strange rock. They were not seeing an object that was merely behaving in a puzzling way. They were seeing something that actively violated that great cosmic silence. They were seeing a rock that had found a voice. And so we return to that darkened room, to the silent hum of servers processing an impossible truth. We return to the Aegis array, the secret sentinel that had, for the first time, heard a voice in the void. For the analysts and physicists tasked with monitoring its data, the world had fractured. Everything they knew about the universe, every law of physics they had memorized, was built on the foundation of that cosmic silence. Now, they were staring at a crack in that foundation, a crack that was growing wider with every passing second. The moment of detection was not one of jubilation or wonder. It was one of quiet, professional panic. The first analyst to verify the signal would not have celebrated. They would have felt a cold dread creep up their spine. Their first, second, and 100th thought would have been the same. This is a mistake. My career is over. I am seeing a ghost in the machine. The scientific method is, at its core, an exercise in profound skepticism, and in the world of military intelligence, that skepticism is amplified 1,000-fold. The immediate imperative was not to understand the signal, but to kill it, to find the flaw, the bug, the reflection, the mundane explanation that would make it go away and allow the world to make sense again. They began a process of elimination that was as brutal as it was systematic. The entire constellation of Aegis satellites was put through a wringer of diagnostics. Was one of the sensors failing? Was a cryogenic cooler malfunctioning, creating thermal noise that mimicked a signal? They took each satellite offline, one by one, rerouting the data through the remaining network. The signal remained, only slightly weaker, its position in the sky unchanged. They cross-correlated the signal's timing with every known astronomical event. Was it a harmonic of a distant pulsar, its radio waves somehow being converted into gravitational waves by a phenomenon we didn't yet understand? No, the timing was wrong. Was it a gravitational echo from a magnetar flare on the far side of the galaxy? No, but the waveform was completely different. They checked for terrestrial interference. Could a new type of experimental aircraft, a secret government project, be generating a local space-time distortion? They compared the signal with flight logs from every classified aerospace program. Nothing matched. They looked for correlations with seismic activity, with ocean currents, even with the subtle gravitational shift caused by the full moon. The signal was indifferent to them all. It was not from Earth. It was not from the sun. The software itself was torn apart, line by line. Could a subtle coding error in the signal processing algorithms be creating a phantom? They ran the raw, unprocessed data through entirely different software models built from the ground up by a separate team. The phantom persisted. With every failed attempt to debunk it, the reality of the signal grew stronger, more monolithic, more terrifying. It was not an error, it was not a glitch, it was real, and it was coming directly, unambiguously, from that faint, insignificant smudge of light we called 3I/Atlas. With the certainty of its existence established, the focus shifted to the nature of the signal itself, and the deeper they looked, the more impossible it became. This was not a simple, repeating beep like the lighthouse pulse of a pulsar. A pulsar is a marvel of nature, a spinning neutron star that sweeps a beam of radiation across the cosmos, but its signal is fundamentally simple. It is the product of rotation, a cosmic metronome. The signal from 3I/Atlas was nothing like this. It had layers. When the analysts decomposed the waveform, they found it was not one signal, but many, all nested inside each other. There was a primary low-frequency carrier wave, the signal's fundamental heartbeat, but encoded upon that wave, through subtle shifts in its phase, its rhythm, was a stream of information. And riding on top of that, at much higher frequencies, were other, denser packets of data. It was like a radio broadcast that contained not just the main program, but hidden sub-channels you could only hear with a special receiver. This complexity, this information density, was the first profound sign of its artificiality. But the true smoking gun, the piece of evidence that removed all doubt, was found in its fundamental structure. The signal's primary repeating block, the basic unit of the message that cycled over and over, was based on prime numbers. The block contained a sequence of pulses that corresponded to the prime numbers 2, 3, 5, 7, 11, and so on. There is no known natural process in the universe that produces sequences of prime numbers. Gravity, electromagnetism, the strong and weak nuclear forces, they operate on the principles of calculus and geometry. They create spirals, spheres, and waves. They do not, however, engage in number theory. Prime numbers are the fundamental atoms of mathematics. They are a concept, an abstraction. To find them encoded in a signal from space is to find a deliberate, undeniable signature of intelligence. It is the universe's equivalent of a calling card. The analogy is simple, but it is the most accurate one we have. Listening to the background gravitational noise of the universe is like standing next to a massive waterfall. You hear a constant, powerful, chaotic roar. It is the sound of nature, of immense energy being released without purpose or design. What the Aegis array detected was the sound of a symphony orchestra playing in the middle of that waterfall. You could still hear the roar, but underneath it, perfectly clear, was music. There was structure, melody, harmony, and rhythm. Nature does not compose music, it creates noise. What was coming from 3I/Atlas was a composition, and the very existence of that composition meant that, somewhere in the galaxy, there was a composer. This realization was the event horizon. The moment the team monitoring the Aegis array crossed that line, the problem ceased to be a scientific one. The carefully constructed protocols, the chain of command that had been designed for nuclear war or satellite collisions, were instantly rendered obsolete. This was a contingency for which no one had planned. The information was escalated, but it moved through channels that had never been used before. It bypassed conventional intelligence agencies. This was not a matter for spies, it was a matter for physicists and four-star generals. A series of meetings were convened in secret, in shielded rooms deep within the Pentagon, in Beijing, in Moscow. The initial conversations would have been fraught with suspicion. The United States, approaching its primary geopolitical adversaries with a story that sounded like science fiction, would have been met with disbelief, with accusations of elaborate deception. Was this a new form of psychological warfare, an attempt to trick them into revealing their own advanced sensor capabilities? But the data was the data. The Americans shared a small, heavily encrypted portion of the signal from the Aegis array, just enough to be verifiable. They provided the precise coordinates and the predicted characteristics of the gravitational wave, and they waited. The Chinese and the Russians, with their own nascent and highly secret space-time monitoring programs far less sensitive than Aegis, but perhaps just sensitive enough, pointed their own instruments toward 3I/Atlas, and they saw it, faint, barely distinguishable from the noise, but there, the pattern matched. The symphony was real. The moment of confirmation changed the geopolitical landscape of the planet overnight. Decades of rivalry, of proxy wars and espionage, of mutual, simmering distrust were rendered secondary by a single terrifying truth. What they were facing was not an alien invasion in the way Hollywood had imagined it. There were no motherships, no invading armies. The threat was infinitely more subtle and more profound. The signal from 3I/Atlas was proof that some other intelligence had mastered gravity. They had learned to manipulate the very fabric of space-time and use it as a communication medium. This represented a leap in physics so far beyond our own that it was functionally equivalent to magic. A civilization that can engineer gravity can, by definition, do anything. They can create limitless energy. They can travel between the stars. They can create weapons that could extinguish a planet with a thought. The fear was not of the messenger, but of the physics. The very existence of this technology, regardless of the content of the message or the intentions of its sender, was a paradigm-shifting threat. If one nation on Earth, and one nation alone, could decipher this physics and learn to replicate it, that nation would become the permanent, unassailable master of the entire planet. The stakes were no longer about territorial disputes or economic dominance. The stakes were existential. This realization led to the most unlikely and most secret alliance in human history. A fragile, unspoken collaboration was formed between the space commands of the world's superpowers. The geopolitical rivalries were not forgotten, but they were suspended. An agreement was reached. This discovery would be contained. The public would know nothing. The wider scientific community would know nothing. It was too dangerous. Humanity, they concluded, was not ready for this knowledge. The anomaly was no longer a scientific puzzle. It was now the most significant global security event in human history. And its first product was a secret, international task force, given a blank check and a single, all-consuming mandate: understand what is coming. That task force, assembled in the deepest secrecy, faced a problem that was almost philosophical in its scale. They possessed a piece of data, the signal that their existing science could not explain. It was an effect without a known cause, a message without a language, a technology without a theory. The brightest minds from the world's defense and intelligence establishments were gathered, but they were staring into an abyss of ignorance. They had confirmed the impossible was real. Now, they had to understand it. Their search for answers did not lead them to the grand, celebrated halls of modern physics. It led them to the dusty, forgotten archives of theoretical science, to the digital graveyards where radical ideas go to die. And it was there, buried under years of neglect, that they found her. They found the ghost who had, unknowingly, written the blueprint for the very thing they were now confronting. Her name was Dr. Ilara Vance. She was not a household name. She did not hold a prestigious chair at a major university. She was a brilliant but ostracized physicist whose career had been quietly and systematically dismantled by the scientific mainstream. Years earlier, while working on the fringes of string theory and quantum gravity, she had published a paper, It was a dense, highly mathematical treatise entitled On the Phenomenon of Gravitational Inscription. The paper was met with a resounding and dismissive silence from the academic community. It was not peer-reviewed in any major journal. It was relegated to a preprint server, a place for speculative, unproven work. Her thesis was considered so outlandish, so disconnected from observable reality, that it was branded as little more than elegant science fiction. She proposed a form of physics that seemed to violate known conservation laws and required the existence of matter and energy states that had never been detected. Her grants were not renewed. Her colleagues distanced themselves. She had committed the cardinal sin of theoretical physics. She had dared to be too imaginative, and so she vanished from the field, another casualty of scientific orthodoxy. But now, in the sterile conference rooms of the secret international task force, her paper had become the most important document on Earth, because in it, she had laid out the only theoretical framework that could even begin to explain the signal from 3I/Atlas. Vance's work was the key. It was the Rosetta Stone that allowed the task force to begin translating the impossible. At the heart of her theory was a radical and profound idea she called the silent beacon hypothesis. It began by attacking the very foundation of SETI, the assumption that advanced civilizations would communicate with radio waves. Vance argued that this assumption was not just wrong, but dangerously naive. It was the product of a young, boisterous species projecting its own technological infancy onto the entire cosmos. Radio, she claimed, is the communication method of primitives. It is loud. A powerful radio signal broadcast across the stars is the equivalent of shouting in a dark, unfamiliar forest. You announce your presence, your location, and your level of technology to anyone who might be listening, without knowing who or what is out there. It is a staggering tactical blunder. Radio is also inefficient. The inverse square law dictates that its signal strength fades dramatically with distance. To send a coherent message to a star 1,000 light-years away would require an astronomical amount of energy. And finally, it is slow, bound by the speed of light. A conversation with a civilization just 50 light-years away would require a century for a single exchange of hello. For a truly ancient, truly advanced intelligence, a Kardashev Type 3 civilization, capable of harnessing the energy of an entire galaxy, radio would be seen as a child's toy. A messy, dangerous, and hopelessly parochial way to talk. The ultimate method of communication, Vance's hypothesis argued, would be the opposite of radio in every respect. It would be silent, requiring incredibly advanced physics to even detect. It would be permanent, capable of carrying a message for billions of years without degradation. And it would be subtle, blending into the natural background of the universe. The truly advanced, she theorized, would not shout. They would write. They would write their messages into the fabric of space-time itself. They would communicate gravitationally. The silence of the Fermi paradox was not, in her view, a sign that the galaxy was empty. It was a sign that the galaxy was mature. It was the sound of a civilization that had learned a vital, perhaps painful lesson, that the universe rewards caution, and that true wisdom is expressed not through shouting, but through quiet, patient listening. The great cosmic silence was not an absence of conversation. It was the respectful hush of a library. We had simply been standing in the middle of it, screaming, wondering why no one was screaming back. But the most breathtaking part of Vance's hypothesis was not the why, but the how. How could a civilization write a message using gravity? This is where her theory made its leap into what was once considered fantasy. She proposed that there exists, in the far upper reaches of the periodic table, an island of stability where super-heavy elements could exist. This is a concept that mainstream physics acknowledges as possible, but Vance went a step further. She theorized the existence of a specific element, one with an atomic number so high it could never be formed in the heart of a star, an element that could only be manufactured. She called this hypothetical substance kenosite. Kenosite in her model was unique. It was a form of exotic matter with extraordinary properties. It was stable, not for seconds or minutes, but for eons, and most importantly, its atomic nucleus was engineered to decay not through the familiar emission of alpha or beta particles, but through the controlled, coherent emission of high-frequency gravitational waves. It was in essence a gravitational laser at the atomic level. A single atom of kenosite would be a transmitter. A sufficient mass of it, properly configured, could broadcast a structured, complex gravitational signal for billions of years. This led to the final, chilling piece of her hypothesis. An advanced civilization would not need to build massive, energy-intensive beacons. They would not need to construct star-sized transmitters. They would simply hijack what nature already provided. They would find a natural, stable, interstellar object, a comet or an asteroid, a simple lump of rock and ice. They would capture it, hollow it out, and inside, they would place a core of kenosite. They would then release this object, this silent beacon, on a carefully calculated trajectory that would carry it through developing star systems over millions of years. The object would be a message in a bottle thrown into the cosmic ocean. To a primitive civilization like our own, it would appear as nothing more than a comet. We would track it with our optical telescopes, measure its composition, and note its passage with mild curiosity. We would be completely deaf to the library of information it was broadcasting, the symphony of gravitational waves that was washing over our planet. 3I/Atlas, the hypothesis concluded, was not a ship, it was not crewed. It was not an emissary coming to make contact, it was a book made of stone and impossible physics, sent on a journey millions of years ago by a civilization we may never meet, carrying a message we were never meant to hear until we had developed the senses to listen. And for the secret task force, this hypothesis crystallized their deepest fear. The threat was not little green men. It was not an alien invasion. The threat was kenosite. The threat was the physics itself. Because a technology that can manipulate gravity is not just a communication device, it is the ultimate source of energy. It is the ultimate engine, and it is the ultimate weapon. A hypothesis, no matter how elegant, is merely a story without proof. Dr. Vance's theory provided the secret task force with a narrative, a potential explanation for the impossible signal, but for it to be more than just speculation, it had to be testable. It had to make predictions about the universe that could be verified or falsified. The silent beacon hypothesis was not just a story, it was a scientific model. And its first, most profound prediction was that 3I/Atlas was not alone. If a galactic communication network truly existed, built from these silent, gravitationally inscribed messengers, then the signal from 3I/Atlas would not be a solo performance. It would be merely the closest, loudest instrument in a vast cosmic orchestra. The rest of the orchestra would still be playing, its sound faint, distant, and blended together into a single, continuous chorus. There should be a background hum, a persistent gravitational wave signal coming from all directions in the sky, the combined whisper of tens of thousands of other beacons scattered throughout the Milky Way. This background hum would be far too faint for the Aegis array to detect. Its instruments were designed for high-frequency signals from nearby sources. But there was another class of instrument on Earth, one designed for the exact opposite purpose, an instrument that had been patiently listening to the slow, deep rhythms of the cosmos for decades. This was the new testing ground. The search for this predicted background hum led the task force to a quiet, unassuming corner of radio astronomy, pulsar timing arrays. A pulsar, the spinning remnant of a dead star, is the most precise clock in the known universe. It sweeps a beam of radio waves across space with a regularity that rivals our best atomic clocks on Earth. For decades, astronomers have been using these cosmic clocks for a very specific purpose. By timing the arrival of pulses from dozens of pulsars scattered across the galaxy, They can create a vast, celestial-scale gravitational wave detector. The logic is beautiful in its simplicity. The entire galaxy, the very fabric of spacetime between us and these pulsars, is the detector. If a very long, low-frequency gravitational wave passes through our section of the galaxy, it will subtly stretch and squeeze the distance between Earth and a pulsar. This stretching would cause the radio pulses to arrive a few nanoseconds earlier or later than predicted. By monitoring a whole network of these pulsars, an array, and looking for a correlated pattern of these timing shifts across the entire sky, scientists can detect the presence of gravitational waves with wavelengths measured in light years. This was the perfect tool. If Dr. Vance was right, if the galaxy was filled with silent beacons, their combined gravitational chorus should manifest as a faint, persistent, non-random noise in the pulsar timing data, a noise that had, until now, gone unnoticed. A secret joint task force, composed of astrophysicists and data analysts sworn to secrecy, was formed. They did not collect new data. They began a process of cosmic archaeology. They were given access to decades of archived data from every major pulsar timing array project in the world. It was a mountain of information, the patient life's work of hundreds of astronomers who had no idea what their data would ultimately be used for. The team began to sift through this mountain, not looking for the cataclysmic bursts of colliding supermassive black holes that the projects were designed to find, but for something far quieter. They were looking for a signal that looked, for all intents and purposes, like noise, a faint, persistent, non-random background hum. For months, they worked in computational silence, developing new algorithms to filter out the known sources of noise, the subtle wobbles of the Earth's rotation, the interference from the solar wind, the intrinsic jitter of the pulsars themselves. They were peeling back the layers of the universe, searching for a ghost, and then they found it, buried deep within the data. Once all the natural sources of noise had been stripped away, a signal remained. It was a faint, persistent, and coherent gravitational wave background. It was not random static, it had a specific spectral shape, a characteristic signature that had been previously written off as an instrumental artifact, a systematic error in the detectors that no one could quite pin down. But when they compared the spectrum of this noise to the spectrum predicted by Dr. Vance's model, the predicted aggregate signal of a galaxy-wide network of silent beacons, the match was perfect. It was the hum, the chorus of the silent orchestra. The task force had found the first independent piece of evidence. The signal from 3I/Atlas was not a singular anomaly. It was simply the melody rising above the quiet, galactic symphony that had been playing all along. This discovery was a monumental step, but it was not enough. The task force needed more. They needed physical evidence, something they could hold in their hands. The second major prediction of Vance's theory offered just that, but it required them to look not to the stars but down into the ancient ice of our own planet. The theory of kinesite predicted that this exotic, gravity-emitting matter would be stable for billions of years, but not infinitely so. Like any element, it would have decay products. As the kinesite core within a beacon broadcast its gravitational message, it would transmute, slowly, into other, more conventional, but still highly unusual, elements. Specifically, Vance's paper predicted that kinesite decay would produce a cascade that resulted in very specific, anomalous isotopes of heavy elements like osmium and bismuth. These would be isotopes with a ratio of neutrons to protons that could not be created through any known natural process. They couldn't be forged in the heart of a star through nucleosynthesis. They couldn't be created by the high-energy impacts of cosmic rays, a process known as spallation. They would be, in effect, the nuclear ash of an alien technology. If other beacons, like 3I/Atlas, had passed through our solar system in the distant past, or even collided with our planet, then traces of this ash, these impossible isotopes, might be found, preserved in the most pristine geological samples on Earth. The search began. A new, clandestine team of cosmochemists and geologists was assembled. Their target, meteorites, specifically a rare class of meteorites called carbonaceous chondrites. These are the oldest objects in our solar system, pristine relics from the time of its formation, 4.6 billion years ago. They are, in essence, fossilized pieces of the protoplanetary disk, and the best place in the world to find them is Antarctica. The vast, sterile ice sheet of the Antarctic plateau acts as a perfect collector and preserver. Meteorites that fall there are buried in the ice, protected from weathering and contamination for millions of years. For decades, scientific expeditions have been harvesting these cosmic stones from the ice. Thousands of them are stored in curated collections around the world. The secret team gained access to these collections. Using new, incredibly sensitive spectroscopic techniques, they began to analyze the samples. They were not looking for new minerals or organic compounds. They were looking for a specific, anomalous isotopic ratio in the heavy metals trapped within the meteorite's rocky matrix. For months, the work was fruitless. Sample after sample showed the familiar, natural isotopic ratios they expected. The osmium and bismuth were exactly as they should be, the product of ancient, nearby supernovae. The frustration within the team grew. Perhaps this line of inquiry was a dead end. Perhaps no beacon had ever struck the Earth. And then they found one. In a single, small carbonaceous chondrite recovered from the Allen Hills region of Antarctica, they found it. The mass spectrometer registered a spike. A tiny fraction of the osmium and bismuth atoms within the sample had the wrong weight. They contained too many neutrons. It was the impossible isotopic ratio predicted by Dr. Vance's paper. It was the ash. The team recalibrated their instruments. They ran the sample again. The result was the same. They frantically searched for any possible source of contamination, any flaw in their methodology. There was none. They began to rapidly test other meteorites from the same region, and they found more. In a handful of other, unrelated samples, they found the same anomalous isotopes. The evidence was clear. Earth had not just been visited by these beacons. In the distant past, our planet, or the asteroids in our solar system, had been dusted with their remains. It was the final, chilling proof that 3I/Atlas was not the first. It was just the latest in a long, silent procession of messengers that had been passing through our corner of the galaxy for, perhaps, billions of years. The net of evidence, which had begun with a single, impossible signal in a secret satellite array, was now tightening. It now connected the farthest reaches of the cosmos, through the patient observations of pulsar timing, to a single, frozen rock on the most remote continent on Earth. The hypothesis was holding. The story was becoming real. With the silent beacon hypothesis now standing on a firm foundation of corroborating evidence, the secret task force turned its full attention back to the source. Back to 3I/Atlas, the background hum and the isotopic ashes were ghosts, echoes of the network. But Atlas was here. It was now. It was a living, broadcasting source. And it held a secret that was far more profound than the mere fact of its existence. It held the message itself. The initial detection had confirmed the signal was complex, layered, and intelligently structured around prime numbers. But this was merely recognizing the cover of the book. Now they had to open it and read the first page. The challenge was monumental. The signal was incredibly faint, a whisper buried in the roar of the cosmos. Extracting the fine details of the information it carried required a signal-to-noise ratio that seemed, at first, impossible to achieve. But the Aegis array was a unique instrument. It was not a single telescope, but a constellation, a network of listeners. By combining the data from every satellite in the array over a period of weeks, by stacking observation upon observation, they could begin to build a picture of the signal that was clearer and sharper than any single observation could ever be. It is a process known as signal integration. the computational equivalent of letting your eyes adjust to a pitch-black room. At first you see nothing, but slowly, patiently, the faint outlines of objects begin to emerge from the noise. For weeks, the dedicated team of cryptographers and signal processors within the task force worked, letting the faint light of the gravitational signal accumulate pixel by pixel, and slowly, the message began to emerge. The breakthrough came when they isolated the primary, low-frequency carrier wave. This was the signal's most powerful and most fundamental component, its constant, rhythmic heartbeat. Once they had filtered out all the higher frequency noise, they found that this carrier wave was not perfectly smooth. It contained a subtle, repeating pattern of modulation, a simple sequence encoded in the very rhythm of spacetime. It was a cosmic, "Hello World" program, a greeting card left on the doorstep of our solar system. The sequence was breathtaking in its elegance and its universality. It was a string of pure mathematics. First, the signal pulsed out a representation of the number pi, accurate to 32 decimal places. A sequence of gravitational waves that, when decoded, mapped out the value 3.141592655, and so on. Pi is a transcendental number, a fundamental constant that describes the relationship between a circle's circumference and its diameter. It is a piece of mathematical truth that would be the same for any intelligent species in the universe, regardless of their biology, their chemistry, or their homeworld. A circle is a circle everywhere. To broadcast pi is to demonstrate a mastery of geometry, to announce that you understand the fundamental shapes of reality. But the message did not stop there. Following the sequence for pi, the beacon then broadcast a second number, the fine structure constant. This number, often represented by the Greek letter alpha, is one of the most mysterious and important constants in all of physics. It governs the strength of the electromagnetic force, the force that holds atoms together and makes light possible. It is a dimensionless constant, a pure number, approximately 1 divided by 137, that determines the very structure of matter and energy. To broadcast the fine structure constant is to announce a mastery of physics, to show that you understand the fundamental laws that govern the universe. There could be no doubt now, this was not a natural phenomenon. This was a deliberate two-part test, a cosmic handshake. The first part, pi, was a test of mathematics. Are you intelligent enough to understand the universal language of numbers? The second part, the fine structure constant, was a test of science. Are you intelligent enough to have discovered the fundamental laws of your own reality? It was the most profound greeting in human history, delivered not by a voice or an image, but by the pure, unadorned beauty of universal constants. It was a message that said, "We are here, we understand the universe, and we assume that, if you can hear this, you do too." For the secret team that made the discovery, the moment was one of profound, earth-shattering awe. The weight of the confirmation, the emotional impact of knowing, with absolute certainty, that we are not alone, was overwhelming. For a brief moment, the geopolitical fears, the terror of the physics, fell away, replaced by the pure, unadulterated wonder of contact. They were the first human beings to read a sentence written by an alien intelligence, but the wonder was quickly tempered by a new and even more daunting realization. As they improved their analysis of the signal, they confirmed their initial suspicion. The beacon was broadcasting on multiple channels. The simple, elegant hello was just the primary layer, the low-frequency signal that was easiest to detect. It was the title of the book, the introduction. But nested within that signal, carried on higher frequency gravitational waves, were unimaginably dense packets of data. The signal was not just a beacon, it was a library, a vast, layered, complex repository of information being broadcast continuously as it sailed through the void. The "Hello World" program was just the key, the primer, designed to let a developing civilization know that there was something to be read. The real message, the encyclopedia of galactic knowledge, was in the higher frequencies. The military and intelligence analysts in the task force immediately understood the implications. They were in a race against time. 3I/Atlas was not going to stop. It was on a trajectory that would carry it out of our solar system and back into the interstellar dark. With every passing day, it grew more distant and its signal grew fainter. There was a limited window of opportunity to record this broadcast, a finite time before even the Aegis array would lose the signal in the background noise. The mission changed. It was no longer just about detection, it was about acquisition. They had to capture every single wave, every single pulse, from every single frequency layer of the broadcast. They had to record the entire library before the librarian left the building. And more than that, they had to begin the impossible task of decoding it. The race to understand the deepest secrets of the universe had just begun. The case for the silent beacon hypothesis was becoming overwhelmingly strong. The signal from space, the chorus from the cosmos, the ashes in the ice, all pointed to the same incredible conclusion. But even this powerful convergence of evidence lacked one critical component: a direct, physical link, a smoking gun. The task force had detected a gravitational broadcast from 3I/Atlas with the Aegis array. They had found evidence of a galactic network in the pulsar timing data. They had found the predicted decay products in ancient meteorites. But these were all separate, disconnected observations. To make the case truly undeniable, they needed to show that the signal from 3I/Atlas was not just a passive stream of information, but that it was having a direct, measurable, physical effect here on Earth in real time. They needed to catch the beacon in the act. And the key to this final, crucial piece of the puzzle lay in one of the most obscure and radical predictions of Dr. Vance's original paper, a prediction so strange that even she had considered it a long shot. The key was to be found deep underground in the quietest, most shielded laboratories ever built by humankind. The search for the smoking gun would take them into the hunt for dark matter. Deep beneath the mountains of Italy, shielded by a kilometer of solid rock from the constant rain of cosmic rays, lies an experiment of profound sensitivity. We will call it Xenon Z. It is a vast, cryogenically cooled vat filled with tons of liquid xenon, an element chosen for its heavy, stable nucleus. The experiment is surrounded by an army of hypersensitive light detectors. Its purpose is to solve one of the greatest mysteries in cosmology, the nature of dark matter. The theory is that the universe is filled with a mysterious, invisible substance that does not interact with light, but which exerts a gravitational pull. As our solar system moves through the galaxy, it should be moving through a constant wind of these dark matter particles. Every second, billions of them should be passing harmlessly through our bodies, through the entire planet. The goal of Xenon Z is to catch one, just one, of these particles in the act of interacting with normal matter. If a dark matter particle were to strike a xenon nucleus, it should produce a tiny, almost infinitesimal flash of light. By detecting this flash, scientists hope to finally glimpse the invisible universe. For years, experiments like Xenon Z have been running in absolute silence and darkness, waiting patiently for a signal that has never come. They have become the quietest places on Earth, paragons of scientific patience. But then, one day, the silence was broken. The detector began to see something. It was not the signal they were looking for. The events in the Xenon Z detector were not the sharp, high-energy flashes predicted by most dark matter models. They were strange, low-energy events, a faint, persistent glow in the liquid xenon that had no apparent cause. The scientists running the experiment were baffled. They checked for every possible source of background radiation, for radon gas leaking from the surrounding rock, for neutron contamination, for electronic noise. They found nothing. The signal was real, but it did not match any known dark matter candidate or any known source of interference. It was an anomaly, a mystery that threatened to undermine years of careful work. The data was published, presented at conferences, and debated endlessly by the particle physics community. It was a frustrating puzzle, but in the classified world of the International Task Force, this news landed like a thunderclap. Because this inexplicable glow, this strange, low-energy signal from deep underground, was something Dr. Vance's theory had explicitly predicted. In the final section of her paper on gravitational inscription, Vance had explored the secondary effects of a kinesite broadcast. The gravitational waves themselves, she argued, were not entirely passive. While they traveled through the vacuum of space with little interaction, her model predicted that when they passed through a dense medium, like a planet, they should interact with spacetime at a quantum level in a very peculiar way. She called this phenomenon framing resonance. The idea is complex, but the analogy is straightforward. Imagine a gravitational wave as a pure musical tone. As this tone passes through the fabric of reality, it doesn't just warp space, it causes the quantum fields that permeate that space to vibrate, to resonate at a specific frequency. This resonance, she predicted, would cause the spontaneous creation of a very specific type of exotic, short-lived secondary particle. These particles would have almost no mass and would interact very weakly with normal matter. They would be, for all intents and purposes, ghosts. But in a sufficiently dense and sensitive detector, like a massive vat of liquid xenon, a tiny fraction of these secondary particles should, on rare occasion, strike a nucleus and produce a faint, low-energy flash of light. The predicted signature of these events, the precise energy and character of the light they would produce, was a perfect match for the mysterious glow being seen in the Xenon Z detector. It was a prediction of breathtaking audacity, and now it appeared to be coming true. The task force now had a clear, testable hypothesis. If the events in the Xenon Z detector were truly being caused by the gravitational waves from 3I/Atlas, then there should be a perfect correlation between the two. The timing had to match. The direction had to match. The test was on. Secretly, the task force gained access to the raw, time-stamped data from the Xenon Z experiment. They then correlated this data with the signal being received at that exact same time by the Aegis array. The result was the smoking gun they had been searching for. There was a direct, one-to-one relationship. The strength of the anomalous glow in the underground detector rose and fell in perfect synchrony with the modulated, prime number-based signal from 3I/Atlas. When the beacon's gravitational wave was at its peak intensity, the number of events in the xenon tank peaked. When the wave was at its trough, the events subsided. They were not just correlated, they were the same signal, seen by two completely different instruments, through two completely different physical processes. But the final, irrefutable proof came from the directionality. The secondary particles produced by framing resonance should travel in the same direction as the gravitational wave that created them. The Xenon Z detector was capable of crudely reconstructing the trajectory of the particles causing the events. When the task force mapped the origin point of the anomalous events, they all pointed back to a single spot in the sky, a spot that was moving day by day, a spot that perfectly matched the known location of 3I/Atlas. This was the moment of global consilience, the point at which all the disparate lines of evidence converged into a single, undeniable truth. Three completely separate and independent fields of science had arrived at the same impossible conclusion. Military space surveillance with the Aegis array had detected a structured artificial gravitational wave signal from an interstellar object. Theoretical physics, through the forgotten work of Dr. Elara Vance, had provided a model that explained how such a signal could be created and why. And now, experimental particle physics, through the strange glow in a dark matter detector deep underground, had provided the physical, tangible proof. The signal from space was directly, physically linked to an effect on Earth. The silent beacon hypothesis was no longer a fringe theory. It was a confirmed reality. The implications were staggering. It meant the laws of physics were incomplete. It meant the galaxy was not silent but whispering. And it meant that an object of profound, unknowable technological sophistication was, at that very moment, passing through our home. The scientific question had been answered. The security question, however, was just beginning. With the smoking gun secured, the weight of certainty fell upon the secret consortium, now formally codenamed Project Chimera. The evidence was no longer fragmentary or circumstantial. It formed a single, coherent, and terrifying picture. Yet, the architects of this project, a small group of generals, intelligence directors, and hand-picked scientists, knew that certainty is the most dangerous bias of all. They were standing on the edge of a discovery that would rewrite not just human history, but the very laws of physics. Before they could take another step, before they could even begin to contemplate the strategic implications, they had to be absolutely, unshakably certain that they were not deceiving themselves. The human mind is a master of seeing patterns where none exist. A group of human minds, working under immense pressure and secrecy, can construct a shared delusion of staggering complexity. They had to ensure they were not the victims of a grand collective folly. They had to try, with all the intellectual firepower they could muster, to break their own discovery. The time had come for a trial by fire. The project initiated a series of brutal, internal stress tests, designed with a single purpose: to falsify the silent beacon hypothesis. The first line of defense against self-deception was the creation of red teams. These were small, independent groups of highly skeptical physicists and signal analysts brought into the project from the outside. They were flown to secure facilities, forced to sign draconian non-disclosure agreements, and then presented with the raw data. But they were not told the truth of its origin. They were told the data, the gravitational wave signal from Aegis, the pulsar timing anomalies, the events in the Xenon Z detector, was the output of a sophisticated simulation, a war game. Their mission, they were told, was to act as a quality control check. They were to analyze this simulated data and find a natural explanation for it, to prove that the simulation was flawed and unrealistic. It was a brilliant piece of misdirection. By framing the problem this way, Project Chimera removed the bias of wanting to believe. The red teams were not trying to find aliens, they were trying to find a bug in a computer program. They were incentivized to be as cynical and as ruthless as possible. For weeks, these teams worked in complete isolation from one another, attacking the data with every tool at their disposal. They proposed exotic, undiscovered astrophysical objects. Could a rapidly spinning, preon-degenerate star, a theoretical object made of the building blocks of quarks, produce a modulated gravitational wave signal through some unknown plasma dynamic? They built the model. It failed. The signal's information content was too high. Could a strange interaction between the solar wind and the Earth's magnetosphere create a correlated noise pattern across the Aegis array and the underground detector? They built the model. It failed. The signal was clearly coming from outside the solar system. One by one, every natural explanation they could devise, no matter how esoteric, was tested and found wanting. At the end of their analysis, each red team, working independently, came to the exact same conclusion. The simulated data they reported back to their handlers was fundamentally unrealistic. There was no known or even plausible natural phenomenon that could account for all the observed effects. The signal, they concluded with a mix of frustration and professional admiration, was unequivocally artificial. The second stress test was a classic technique from experimental science, deployed on a global and unprecedented scale: the blind analysis. The leadership of Project Chimera understood that even with the misdirection of the red teams, a subtle bias could have crept into their own analytical procedures. They needed to know if other scientists with no context whatsoever would see the same thing. They took portions of the raw data from the Aegis array, small snippets of the gravitational wave signal lasting only a few hours. They stripped this data of all identifying information. The timestamps were altered. The celestial coordinates were scrambled. The signal intensity was rescaled. The data was rendered completely anonymous, a contextless stream of numbers. These data packets were then sent, through secure, back-channel academic contacts, to a handful of the world's leading signal processing laboratories. The labs were told the data came from a new, experimental sensor technology, and they were being contracted to perform a simple noise analysis. The task was simple: determine if the data contained any coherent, non-random signals. The results began to trickle back, and they were all identical. Each lab, from Germany to Japan, independently ran the data through their own proprietary software, and each lab reported back the same finding. The data was not pure noise. It contained a faint but clear, coherent signal, a signal with a complex modulated structure. A signal, they noted with academic curiosity, that appeared to have a repeating pattern based on prime numbers. They had no idea they were confirming first contact. To them, it was just an interesting technical problem. But for Project Chimera, it was the ultimate replication. The signal was not a phantom created by their own software. It was an objective feature of the data, detectable by anyone with the right tools, anywhere in the world. The final and most rigorous test was the move from passive analysis to active experimentation. The goal was to design an experiment that would either prove the hypothesis beyond all shadow of a doubt, or shatter it completely. The adversarial collaboration was born. The task force identified the most vocal and intelligent critics of the silent beacon hypothesis from within their own ranks. These were the scientists who, despite the mounting evidence, still harbored doubts. They were then paired with the hypothesis's strongest proponents. This combined team was given a single directive: design the definitive experiment. The focus of their experiment was the smoking gun itself, the anomalous events in the Xenon Z detector. If these events were truly being caused by secondary particles generated by the gravitational waves from 3I/Atlas, then the signal should exhibit a specific, predictable modulation caused by the rotation of the Earth. It's a phenomenon known as diurnal modulation. The reasoning is as follows. As the Earth spins on its axis, the amount of rock and matter that the signal has to pass through to reach the detector changes. When 3I/Atlas is directly overhead, its signal passes through only the atmosphere and the thin roof of the underground lab. When it is on the opposite side of the planet, its signal must pass through the entire 12,000-kilometer diameter of the Earth to reach the detector. A planet is not transparent, even to ghostly, weakly interacting particles. The dense rock of the Earth's crust and mantle should absorb a small but measurable fraction of them. Therefore, the team predicted the number of events detected in Xenon Z should be slightly higher when 3I/Atlas was in the sky above the detector, and slightly lower when it was on the other side of the world. They would see a daily rhythm in the signal, a 24-hour cycle that rose and fell in perfect time with the Earth's rotation relative to the object's position in the sky. To find such a pattern would be irrefutable proof of the signal's extraterrestrial origin. Its absence would be a devastating blow to the theory. The experiment was set. For 30 days and 30 nights, the team monitored the data from Aegis and Xenon Z in perfect synchrony, tracking the daily dance of the Earth and the beacon, and when the data was analyzed, the pattern was there. A clear, unambiguous, 24-hour sine wave, rising and falling exactly as predicted. Every test had been passed. Every attempt to break the hypothesis had failed. The internal confidence level within Project Chimera, which had been high, now reached the level of near absolute certainty. The trial by fire was over. The object was real. The The signal was artificial, the theory was correct, there were no more comfortable doubts to hide behind. They were now standing in the full, blinding light of the truth and had to face the consequences. But even in the face of near certainty, in the blinding light of what seemed to be an undeniable truth, the discipline of science demands one final act of intellectual rigor. It demands that you give your enemy their sharpest sword. Before the leaders of Project Chimera could fully accept the world-altering implications of their discovery, they had to confront, with honesty and intellectual courage, the strongest possible counterarguments. They had to inhabit the mind of the skeptic, to argue against themselves with more passion and more ingenuity than any outside critic could ever muster. This is the process of steel manning, not straw manning. You do not build a flimsy caricature of your opponent's position to easily knock it down. You build it into a fortress of logic and reason, and then you see if your own evidence is strong enough to breach its walls. For the scientists within the consortium, this was the final, and perhaps most important, phase of their work. They had to give the mundane, the natural, and the merely instrumental one last chance to win the day. The strongest, most elegant counterargument came not from a rejection of the data, but from a reinterpretation of its source. It granted that the signal was real, that the gravitational waves were genuine, but it proposed a different composer. The argument was that 3I/Atlas itself was not a piece of technology, but an entirely new, entirely natural, and entirely unknown type of astrophysical object. The universe is a place of infinite and bizarre variety. We are constantly being surprised by new classes of stars, new types of nebulae, new phenomena that defy our neat categorizations. What if 3I/Atlas was simply the first of its kind we had ever seen? Theorists within the project began to sketch out the possibilities. Perhaps it was the remnant of an axion star, a hypothetical body made not of atoms, but of the elusive axion particles proposed to be a component of dark matter. If such a star was spinning at a furious rate, and if it had a slight asymmetry in its structure, it could, theoretically, emit gravitational waves. Or perhaps it was something even more exotic, a prion-degenerate object. Prions are the hypothetical building blocks of quarks and leptons, the most fundamental particles we know. If prions are real, it's possible that under conditions of extreme gravity, a star could collapse into a ball of pure prions, a state of matter so dense it would make a neutron star look like a cloud of gas. Such an object would be tiny, perhaps no bigger than a city, but would contain the mass of a large asteroid. If it was spinning and oscillating, its physics would be utterly alien to us. The signal we were detecting, this argument proposed, was not a language. It was merely the natural, rhythmic byproduct of this exotic object's physical state, its spin, its vibrations, its magnetic field. The prime numbers, the nested frequencies, the mathematical constants, they were not a message, they were a coincidence. A cosmic pareidolia where the desperate, pattern-seeking human mind was seeing intelligence in what was merely complex, but ultimately mindless, physics. It was a powerful and humbling argument. It reminded everyone that our knowledge of the cosmos is a tiny island in a vast ocean of ignorance, and that it is always more likely that we have discovered a new kind of fish than a mermaid. The second fortress of doubt was built on a foundation of instrumental uncertainty. It was an argument that preyed on the project's greatest vulnerability, its secrecy. The entire discovery rested, primarily, on the data from a single, one-of-a-kind, and highly classified instrument, the Aegis Array. No civilian instrument on Earth had the sensitivity to verify the high-frequency gravitational wave signal. LIGO and Virgo were deaf to it. This meant that the most crucial piece of evidence in the entire puzzle existed inside a black box. No one outside of Project Chimera could independently check the data, scrutinize the hardware, or audit the software. This raised a terrifying possibility. What if the signal was not from space at all, but was an artifact of the instrument itself? The Aegis array was a constellation of multiple satellites, all working in concert. A systematic, correlated error, a subtle flaw that was common to the sensors or the timing software on every single satellite, could theoretically mimic the appearance of a coherent astrophysical signal. Imagine a choir where every singer has the exact same, almost imperceptible tremor in their voice. A single singer's tremor might be dismissed as a fluke, but when they all sing together, that tiny correlated tremor could combine, amplify, and create the illusion of a new, deliberate note that wasn't actually in the music. The Aegis array could be a choir of flawed singers, and the signal from 3i/Atlas could be their phantom, collective note. Yes, there was corroborating evidence from the pulsar arrays and the dark matter detector, but those signals were faint, detected at the very edge of significance. It was possible, the argument went, that those were real, but unrelated, anomalies, and that the over-eager minds within the task force had simply forced them to fit a narrative that was being dictated by a flawed primary instrument. Without independent verification from an instrument built by a different team, in a different country, based on a different design, the claim would always rest on a foundation of faith, faith in a black box. The third and final counterargument was perhaps the most philosophically potent. It was an attack on the very logic of the silent beacon hypothesis itself. It was a critique of its elegance, its sweeping simplicity. The hypothesis required that all advanced, star-faring civilizations everywhere in the galaxy had not only discovered the same impossibly advanced physics of kinesite, but that they had all, independently, made the exact same conservative, cautious decision to use it for communication in this one specific way. They all chose to build silent beacons. They all chose to hide their signals from primitive species. They all chose to participate in this slow, patient, non-interventionist network, this galactic monolith. Assumption, the critics argued, seemed deeply improbable. Evolution, whether biological or technological, tends toward diversity, not uniformity. We would expect a galaxy full of life to be a chaotic, noisy, and diverse place. There should be some civilizations that use radio. There should be some that build Dyson spheres and other obvious megastructures. There should be some that expand aggressively. There should be some that are quiet. For all of them to converge on this single, highly specific, and deeply conservative philosophy of non-interference seemed to defy all logic. The silence of the Fermi paradox, this argument concluded, was more likely explained by the absence of others, or by some great, universal filter that prevents civilizations from reaching this stage, than by a galaxy-wide secret society of silent librarians. The silent beacon hypothesis, for all its beauty, required a level of galactic conformity that felt more like a plot device than a plausible reality. These three arguments, taken together, formed a powerful and sobering case for the mundane. They offered a way out, a path back to a universe that, while perhaps lonely, was at least understandable. For the members of Project Chimera, this was their final temptation: to accept these doubts, to classify their findings as inconclusive, and to return to the comfortable silence they had known before. But they did not accept them. The intellectual fortresses of doubt, so carefully constructed, were dismantled, piece by piece, not by faith, but by the relentless pressure of the data itself. The walls were breached, and the case for the extraordinary became the only one left standing. The first counter-argument, that 3i/Atlas was merely a new, exotic, but natural object, was the most difficult to refute because it hinged on our own ignorance. How can you prove something isn't a natural phenomenon you haven't discovered yet? You cannot, but you can assess its probability. And the probability that any natural object, no matter how bizarre, could mimic the specific characteristics of the Atlas signal was calculated to be infinitesimally small. A spinning, asymmetrical star might produce a simple, repeating gravitational wave, like a lighthouse beam. It might even produce a signal with a few harmonics, a few nested frequencies, but it could not produce a signal with the sheer, layered complexity and deliberate structure seen in the broadcast. The core of the rebuttal lay in a concept known as information density. The signal from 3i/Atlas wasn't just a pattern, it was a message, and it was dense with information. It was encoding mathematical constants. It was structured around prime numbers. Natural processes, even the most complex ones, are governed by the laws of physics and tend towards simplicity, towards the path of least energy. They do not spontaneously engage in higher mathematics. To believe the signal was natural was to believe that a waterfall, through the random motion of its water molecules, could not only compose a symphony, but also embed the blueprints for the concert hall in its harmonies. It was possible, in the same way that a monkey typing randomly for an infinite amount of time could eventually produce the complete works of Shakespeare. It was possible, but it was not plausible. The sheer, unadulterated information content of the signal was the ultimate rebuttal. It was a fingerprint of mind. The second argument, the fear of a systematic instrumental error in the Aegis array, was far more concrete and therefore far easier to dismantle. While it was true that the Aegis array was a black box to the outside world, the corroborating evidence from other, completely independent instruments could not be so easily dismissed. This is the principle of consilience in science, the convergence of evidence from unrelated lines of inquiry. Project Chimera did not have one miraculous instrument, they had three. They had the Aegis array, listening to the high-frequency gravitational waves. They had the global network of pulsar timing arrays, listening to the low-frequency background hum. And they had the Xenon Z dark matter detector, observing the secondary particle effects here on Earth. For the instrumental error argument to hold, it would require a coincidence of astronomical proportions. It would require a systematic flaw in the Aegis satellite constellation that just happened to perfectly mimic the signal predicted by Dr. Vance's theory. At the same time, it would require a completely separate and unrelated systematic flaw in the decades of data from a dozen different radio telescopes in the pulsar timing network, a flaw that also just happened to perfectly match the predicted background hum. And finally, it would require a third, completely unrelated source of noise or contamination in a shielded, underground particle detector that just happened to perfectly correlate in both time and direction with the phantom signal from the flawed military satellites. The odds of three different types of instruments operating on completely different physical principles in completely different environments, all having correlated, systematic errors that perfectly and coincidentally mimic the exact predictions of a single, unified theory, are not just low. They are so vanishingly close to zero as to be statistically indistinguishable from impossibility. It was not one instrument pointing to the unbelievable. It was three separate instruments, all pointing to the same, inescapable conclusion. The black box of the Aegis array was no longer a weakness. It was simply the first and loudest of a chorus of credible witnesses. The final objection, the philosophical argument against the galactic monolith of a single universally adopted communication method, was the most subtle. It could not be defeated with data, but with a refinement of the hypothesis itself. The critics were right. It was illogical to assume all advanced civilizations would behave in the same way. But, the proponents argued, what if the choice to use silent beacons was not just about communication? What if it was the inevitable end point of a deeply conservative, and perhaps deeply fearful, galactic philosophy? The hypothesis was revised. The goal of the network was not primarily to talk, but to listen, not to announce one's presence, but to learn, silently and safely, from the broadcasts of others. In this revised model, the famous zoo hypothesis, The idea that we are being deliberately left alone is not the cause, but a consequence. The core tenet of the Galactic Club is one of absolute non-intervention. Why? Perhaps because of a painful, shared history. Perhaps the first civilizations to shout with radio waves attracted the wrong kind of attention. Perhaps the early days of the galaxy were a dangerous and chaotic time, a dark forest, where any detected signal was a potential target. In such an environment, only the quietest and most cautious civilizations would survive. Over billions of years, this would create a powerful evolutionary pressure. Civilizations would learn that megastructures, loud radio signals, and rapid, visible expansion were invitations to disaster. The survivors would be those who learned to hide, to observe, and to share knowledge in the most subtle and least detectable way possible. Gravitational beacons are the ultimate expression of this philosophy. They are the ultimate non-interventionist technology. They allow a civilization to add its knowledge to a permanent galactic library without ever revealing its own location, its capabilities, or even its existence to a potentially hostile neighbor. The silence of the Fermi paradox, then, is not the silence of an empty galaxy, it is the silence of a galaxy that has learned its lesson. The reason we see no other signs is because the only civilizations left are the ones who have learned not to make any. The galactic monolith was not a choice, it was a survival strategy, and with that final chilling rebuttal, the case was closed, the doubts were silenced. The path forward was now terrifyingly clear. With all counter-arguments addressed, all internal doubts assuaged, the members of Project Chimera crossed a final, internal Rubicon. They moved from a state of radical uncertainty to one of profound and unsettling acceptance. The disparate pieces of evidence, the signal, the hum, the ash, the glow, were no longer separate anomalies to be investigated. They were now the interlocking components of a single, comprehensive model of the cosmos. A model that was darker, stranger, and more magnificent than anything humanity had ever conceived. The time had come for the grand synthesis. The time had come to build a coherent picture of the galactic gravitational network. The picture they assembled was one of almost unimaginable scale and patience. It described a slow, deliberate, and galaxy-wide information sharing system, a library built to last for billions of years. The architects of this network were unseen, their age and origins unknown, but their methods were now becoming clear. The life cycle of a beacon, the central element of the network, began with an act of cosmic engineering so advanced it bordered on creation. A civilization, having reached a state of technological maturity far beyond our own, first had to master the physics of kinesight. They had to learn how to manufacture this impossible, super-heavy element, atom by atom, in quantities sufficient to create a gravitational broadcast. This act alone would require the energy output of a star, marking them as a Kardashev Type II civilization at a minimum. Once the kinesight was created, the next step was inscription. This was not a crude process of simply placing a lump of exotic matter into a rock. The information, the libraries of science, philosophy, and art, had to be encoded into the very structure of the kinesight core. The complex, nested frequencies of the gravitational wave broadcast were determined by the precise quantum state of the kinesight atoms. To inscribe the data was to engineer the material at a subatomic level, a form of quantum data storage that would make our own digital technologies look like marks on a clay tablet. The energy and technical requirements for this process, the model detailed, were staggering, likely requiring the computational power and manufacturing capability of an entire solar system. This was the work of a Type III civilization, one that had mastered the resources of its entire galaxy. Having inscribed their knowledge, the civilization would then select a vessel, a natural, stable, interstellar object captured from the void. They would hollow out this comet or asteroid, place the kinesight core within it, and then use their mastery of gravity to place it on a new trajectory. Not a random trajectory, but a carefully calculated delivery route, an orbital path designed to intersect with a high number of developing star systems over the course of millions or even billions of years. The beacon would then be released, a silent, patient messenger sent forth on a journey through the long galactic night. The properties of the network that emerged from this model were as alien as the technology that built it. It was, first and foremost, decentralized. There was no central server, no single point of origin. Any civilization that reached the required level of technological maturity could, in theory, add its own books to the library, launching its own beacons into the interstellar currents. It was a peer-to-peer network on a galactic scale. It was also asynchronous. There was no expectation of a real-time conversation. The messages were sent with the understanding that they might not be received for 100 million years. It was a form of communication that operated on geological and evolutionary timescales, a conversation between epochs, not individuals. And finally, it was permanent, or as close to permanent as anything in the universe can be. The Kinosite cores were engineered to be incredibly stable, broadcasting their message for billions of years before their energy was spent. The stone and ice of the cometary shells protected them from the radiation and dust of the interstellar medium. The library was built to survive the death of its own authors, to carry their knowledge across the eons, a final, indelible legacy. For the scientists and military leaders of Project Chimera, this model was both awe-inspiring and deeply humbling. It painted a picture of a galaxy that was not empty, but filled with the patient, silent thoughts of intelligences so ancient and so powerful that we could barely be considered their contemporaries. We were not alone. We were simply infants, living in a world built by and for adults, completely unaware of the vast architecture of knowledge that surrounded us. But it was the final implication of the model that transformed this sense of awe into one of cold, existential fear. As the physicists of Project Chimera dug deeper into the predictions of Dr. Vance's theory, they confronted the true nature of framing resonance, the phenomenon responsible for the glow in the xenon Z detector. The gravitational waves, they realized, were not entirely passive carriers of information. They had a subtle but persistent physical effect on reality itself. The secondary particles they generated were not just a curious side effect, they were an active agent. The model proposed that these waves and the particles they created could subtly nudge quantum processes. They could alter the probabilities of certain quantum events, a phenomenon that the team termed probabilistic framing. The analogy is like a field of falling leaves. The path of each individual leaf is random and unpredictable. But if you introduce a very gentle, almost imperceptible, but persistent crossbreeze, you can, over time, influence the overall pattern of where the leaves land. You are not controlling any single leaf, but you are framing the probability of its final destination. The gravitational waves from the network, the model suggested, were a galactic-scale crossbreeze, subtly influencing the quantum randomness of the universe. For what purpose? The possibilities were as terrifying as they were profound. Perhaps the network was a vast cosmic engineering project designed to stabilize the energy of the vacuum, to prevent the universe from collapsing in a future phase transition. Perhaps it was a terraforming tool, subtly guiding the evolution of life on nascent worlds by altering the probabilities of key genetic mutations. Or perhaps, and this was the possibility that chilled the military leadership to the bone, it was a weapon of unimaginable subtlety and power, a technology that could, over time, rewrite the laws of physics in a target star system, destabilize its sun, or prevent its local life from ever reaching a technological stage. The network was not just a library. It might be a tool for galactic-scale governance, a stability mechanism, or an instrument of silent, patient warfare. And this, finally, explained the intense, overriding, and fearful interest of the world's militaries. They had not discovered a message. They had discovered a new fundamental force of nature being wielded as a technology for a purpose they could not begin to comprehend. The race to understand that purpose had now become the single most important long-term goal for human survival. A model, however complete, is only as good as its ability to predict the future. The grand synthesis of the galactic gravitational network was a monumental intellectual achievement for Project Chimera, a coherent story that finally tied together all the impossible facts. But to be truly confident, to move from a state of secret knowledge to one of actionable intelligence, they needed more. They needed to know what would happen next. A true scientific theory does not just explain the past, it provides a clear, testable roadmap of the future. The model they had built was not just a narrative, it was a machine for generating predictions. And it made several that were concrete, unambiguous, and, most importantly, falsifiable in the near term. These predictions became the new strategic focus of the project, a pathway that could, one day, lead this extraordinary discovery out of the world of classified secrets and into the realm of public, verifiable science. The first and most immediate prediction concerned the background hum. The task force had found the faint, aggregate signal of the network by painstakingly re-analyzing decades of old data from pulsar timing arrays. It was a remarkable feat of data archaeology, but it was still a discovery made by looking backward. The model predicted that this hum was not a phantom of old data, but a persistent, physical feature of our universe. It should be detectable now, and with greater clarity than ever before. The next generation of civilian gravitational wave detectors, massive, continent-spanning projects like the planned Einstein telescope in Europe or the Cosmic Explorer in the United States, were being designed with a sensitivity orders of magnitude greater than anything that had come before. Their primary mission was to detect the gravitational waves from the dawn of time, the echoes of the Big Bang, but the model predicted they would find something else entirely. It predicted that the moment these new observatories came online, they would be flooded with a faint, coherent, low-frequency gravitational noise from all directions in the sky, a noise that would precisely match the spectrum of the signal found in the pulsar data. This prediction transformed the public, civilian search for gravitational waves into an unwitting confirmation of Project Chimera's greatest secret. The world's astronomers, in their noble search for the universe's origins, would accidentally stumble upon the clearest evidence of its inhabitants. For the leaders of the task force, this created a ticking clock. They had, at most, a decade or two before the secret would be blown wide open, not by a leak, but by the relentless march of public science. The second prediction was statistical, but no less profound. If 3I/Atlas was not a unique object, but merely one of thousands of similar beacons traversing the galaxy, then we should expect to see more of them, many more. Our ability to scan the skies for small, fast-moving objects is improving at an exponential rate. Projects like the Vera C. Rubin Observatory in Chile are designed to survey the entire visible sky every few nights, creating a motion picture of the cosmos of unprecedented depth and scale. The model predicted that as these new sky surveys came online, they would begin to detect a statistical excess of interstellar objects. And more than that, these objects would not be on random trajectories. A significant fraction of them would be found on what the model called delivery routes, highly efficient, low-energy paths that intersect with a large number of star systems. Just as a shipping company does not send a container ship on a random path across the ocean, but along established, efficient shipping lanes, the builders of the network would have launched their beacons on trajectories optimized for visiting as many potential ports of call as possible. The prediction was clear. In the coming years, astronomers would not just find more interstellar objects, they would find that a suspicious number of them were following a surprisingly narrow set of galactic highways. The discovery of 3I/Atlas was not the end of the story. It was the beginning of a traffic report. The third and final prediction was the most tantalizing of all, for it promised to unlock the very content of the message itself. It concerned the deeper, higher frequency layers of the 3I/Atlas broadcast. The model predicted that buried within these dense data streams, there must exist a Rosetta Stone. The builders of the network, in their infinite patience, would have understood that any civilization capable of detecting the signal would have no way of understanding its language. They would need a primer, a universal dictionary to get them started. This Rosetta Stone, the theory went, would be a comprehensive tutorial on physics and mathematics, starting from the most basic first principles. It would begin with simple concepts, integers, prime numbers, basic geometry, and build, layer by layer, up to the most advanced concepts of quantum field theory and the nature of space-time itself. It would be a step-by-step guide to the universe, a self-teaching manual that would allow any intelligent species, no matter how different their biology or their native language, to learn the universal language of reality. By following this primer, a species would not only learn the vocabulary and syntax of the beacon's broadcast, but they would also be brought up to speed, given the fundamental scientific knowledge required to understand the rest of the library. Decoding this Rosetta Stone, this universal primer, became the primary, all-consuming goal of the cryptographers and analysts within Project Chimera. It was no longer just a race to record the data before the beacon flew out of range. It was a race to learn. The survival and future of the human race might not depend on building weapons or defenses, but on something far more fundamental: our ability to listen and our capacity to understand. The path to becoming a galactic citizen, it seemed, began with a lesson, and class was now in session. The confirmation of the galactic gravitational network and the ongoing decryption of its primer was a moment that fundamentally and irrevocably altered humanity's place in the universe. It was a paradigm shift so profound that no prior scientific revolution, not Copernicus, not Darwin, not Einstein, could compare. For our entire history, we have defined ourselves through two competing narratives. The first was a story of cosmic significance, the belief that we were special, unique, placed at the center of creation for a divine purpose. The second, born of the scientific age, was a story of cosmic loneliness, the suspicion that we were a magnificent, but ultimately meaningless, accident, a fleeting flicker of consciousness in an otherwise dead and empty void. The discovery of the network annihilated both narratives at once. We were not special, and we were not alone. The truth was something far more humbling and far more terrifying. We were simply primitive. The universe was not silent. It was full of whispers in a language we were too deaf, too technologically infantile to hear. We were like an undiscovered tribe, living on an isolated island, completely unaware that a global network of fiber optic cables, carrying the sum of all human knowledge, was running silently beneath the sand at our feet. The discovery did not elevate us, it demoted us. We were no longer the sole proprietors of intelligence in the cosmos. We were merely the newest, and perhaps the dimmest, students in a school of unimaginable antiquity. This realization rippled through the secret corridors of Project Chimera, not as a wave of celebration, but as a quiet, creeping sense of existential dread. The feeling of cosmic loneliness, which had haunted thinkers for centuries, was suddenly replaced by a far more unsettling feeling, the feeling of being watched. The silent beacon hypothesis, in its final revised form, was a confirmation of the zoo hypothesis, but with a chilling and impersonal twist. The zoo hypothesis has long been a proposed solution to the Fermi paradox, suggesting that advanced alien civilizations know we are here, but deliberately hide themselves from us, treating our planet as a wildlife preserve or a sociological experiment. They observe us from a distance, but do not interfere. The discovery of the gravitational network confirmed the observation, but it suggested a motive that was far colder and more indifferent than we had ever imagined. The zookeepers don't visit, they don't walk through the enclosure, they don't interact with the animals. They just leave educational materials, books written in the language of physics, scattered around the habitat, and they wait. They wait for the animals to evolve to a point where they can read. The lack of direct contact was not a sign of respect, necessarily. It was a sign of immense, almost unimaginable patience. The beings that built this network were not our contemporaries. They were playing a game on a scale of millions, or even billions of years. To them, the entire span of human civilization, from the first stone tools to the splitting of the atom, would be a footnote in a much longer story. We were not a civilization to be contacted. We were a biological and sociological process to be observed from a safe distance over the long arc of geological time. This new understanding of our place in the cosmos raised a host of profound and deeply unsettling philosophical questions, questions that were now being debated in the most secure rooms on the planet. What is our purpose? What is the purpose of any developing intelligence? Are we merely students in a vast, impersonal galactic schoolhouse, expected to learn the curriculum before we are allowed to graduate? Is our entire technological and social development simply a long, slow process of catching up, of rediscovering the knowledge that has been waiting for us all along? The idea of probabilistic framing, the subtle nudging of quantum events by the network's gravitational waves, added a terrifying layer to this question. Was our development being guided? Was the very evolution of life on Earth, the Cambrian explosion, the rise of mammals, the emergence of consciousness, subtly influenced by this cosmic background radiation? Were we a wild experiment or a cultivated one? The sheer conservatism of the network, its absolute dedication to the principle of non-interference, suggested a deep, perhaps fearful, respect for some unknown rule. What were they afraid of? Were they protecting us from some galactic danger we could not yet comprehend? Or were they protecting themselves and the rest of the galaxy from us? Perhaps every young, boisterous civilization that learns to shout with radio waves represents a potential threat, a wild card that could disrupt the quiet, stable order of the galactic community. Perhaps this non-interference was not a kindness, but a quarantine. The ultimate effect of this discovery was the permanent shattering of our species' sense of self-importance. For the handful of people within Project Chimera who knew the truth, the old world of human affairs, of nations, of politics, of ideologies, suddenly seemed small, provincial, and almost comically naive. All of our triumphs and all of our tragedies, all of our wars and all of our art had played out on a tiny, isolated stage, while the real drama of the cosmos unfolded silently and invisibly all around us. We were not the main characters in the story of the universe. We were not even a supporting role. We were, at best, part of the scenery, a minor detail in a narrative of incomprehensible scope and age. This was the great human demotion, the final and most brutal removal of humanity from the center of creation. We were not at the center of the solar system. We were not the pinnacle of biological evolution. And now we knew we were not the sole inheritors of consciousness. We were latecomers to a very old and very quiet party, and we had only just realized that the music had been playing all along. The question that now hung over the future of our species was a simple one. What does the student do upon realizing they are in a classroom full of masters? Do they raise their hand and announce their presence, or do they sit silently and begin to do the reading? For the members of Project Chimera, these philosophical questions, however profound, were a luxury. while the scientists and theorists grappled with the humbling realities of humanity's new place in the cosmos, the military and strategic leaders of the consortium were forced to confront a far more immediate and dangerous set of consequences. The paradigm shift was not just intellectual, it was geopolitical. The discovery of the galactic gravitational network had, in a single moment, redefined the very meaning of power on Earth. The fragile alliance between the United States, China, and Russia was born of a shared existential fear, but fear is a temporary glue. As the initial shock wore on, it was inevitably replaced by something far older and more familiar: ambition. The knowledge contained within the 3i/Atlas broadcast was not just a key to understanding the universe, it was a key to controlling it. And in the silent halls of power in Washington, Beijing, and Moscow, a new and terrible calculation was being made. The nation that could first decipher the message and, more importantly, replicate the Kinosite inscription technology would not just gain a strategic advantage, it would gain everything. The ability to manipulate gravity and space-time is the ultimate military and economic high ground. It is a power so absolute that it renders all other forms of power, nuclear, economic, political, obsolete. A nation with that technology could encase its enemies in inescapable gravitational bubbles. It could move fleets and armies instantaneously. It could generate limitless, clean energy, making all other resources irrelevant. It would be the final checkmate in the long, bloody game of human history. And so, even as the scientists of Project Chimera worked together in a fragile truce, a new Cold War, colder and more secret than any that had come before, began to dawn. The race was on. A silent global arms race, fought not with spies and bombers but with cryptographers and quantum physicists. Within the walls of Project Chimera, this new strategic reality created a deep and dangerous schism. The debate over what to do next was no longer a purely scientific one. It was now a question of strategy, of risk, and of the very future of the human species. The central, agonizing question was this: should we respond? Should we, having learned to hear the whispers of the network, attempt to add our own voice to the chorus? The argument for responding was one of opportunity. We had been handed the keys to the kingdom. The 3i/Atlas library could contain the answers to all of our most pressing problems: the cure for disease, the secret to faster-than-light travel, the physics of clean energy. To remain silent, to patiently listen and learn for centuries, was to condemn billions of human beings to lives of unnecessary suffering and limitation. To announce our presence, to say hello back, might accelerate our entry into the galactic community. It might open a dialogue. It was a gamble, but it was a gamble for a prize of unimaginable value. But the argument against responding was one of profound existential terror. This argument was rooted in the very nature of the network itself. Its defining characteristic was its silence, its caution, its deep-seated philosophy of non-interference. That isn't it. For us, a species barely out of its technological infancy, to suddenly shout into this quiet, ancient library would be an act of breathtaking arrogance. It would be the equivalent of a child, having just learned to speak, bursting into a room of silent, meditating monks and demanding their attention. We had no idea of the rules. We had no idea of the dangers. We did not know who or what else might be listening. The dark forest theory, once a mere science fiction conceit, was now a plausible, terrifying reality. In a dark forest, the safest course of action is always to remain silent. To make a sound is to reveal your location to any predators that might be lurking in the shadows. To respond to the beacon would be to light a fire in the middle of that forest, a fire that could not be extinguished. We would be announcing our existence, our location, and our technological level to the entire galaxy, with no knowledge of who our neighbors were or what their intentions might be. The risk was not just war, it was extinction. This debate raged in secret, a high-stakes philosophical wargame played out by the most powerful people on the planet. For now, the voices of caution have won the day. The consensus for the moment is to remain silent, to listen, to learn, to record every scrap of data from 3i/Atlas before its signal fades forever, and to pour all of our collective resources into the monumental task of decoding its library. A roadmap for humanity's future, a secret charter, was drafted and agreed upon by the leaders of the consortium. Its primary directive is to understand and then replicate the physics of kinesite. A new Manhattan Project, on a global and clandestine scale, was initiated. Its goal is not to build a bomb, but to master a new fundamental force of nature. The public would see only a quiet, inexplicable surge in funding for theoretical physics, for materials science, for quantum computing. They would not know that these disparate, seemingly unrelated research programs were all being secretly coordinated, all aimed at a single, world-altering goal. But the most chilling part of this new roadmap was its contingency planning. The discovery of probabilistic framing meant that the network was not necessarily benign. Its ability to subtly influence quantum reality could be a stabilizing tool, or it could be a weapon. What if its true purpose was hostile? What if the network was designed not to educate, but to control, to pacify, to prevent young aggressive species like our own from ever becoming a threat to the established galactic order? Understanding the true purpose of the network and the ultimate intent of its creators became the single most important long-term intelligence objective for the human race. The future was no longer a matter of decades or even centuries. The strategic planning of Project Chimera was now operating on a timescale of millennia. The student had entered the classroom, but the first and most important lesson was to determine if the teachers were benevolent or if the school was, in fact, a prison. And so, we are left here, in the present moment, suspended between a revelation and a response. The story of 3i/Atlas, as we have told it, is the story of a secret. But as we look to the darkening sky, we see the object itself, a silent messenger of stone and exotic physics, continuing its inexorable journey. It is now receding from us, moving back out into the interstellar dark from whence it came. The faint gravitational song it has been broadcasting across our world for these past months is growing quieter with every passing hour. We have a limited window to listen, a final, fleeting opportunity to record the contents of this galactic library before its signal becomes too faint for even the Aegis array to hear. Before it is lost once more in the background hum of the cosmos. The secret global Manhattan Project, Project Chimera, is in a desperate race against this fading light, capturing every last vibration, archiving every pulse, in the hope that what they are saving contains not just knowledge, but wisdom. The message that 3i/Atlas carries is a legacy from unknown, ancient intelligences, a gift of knowledge from a civilization or civilizations we may never meet. It could contain anything. It could hold the secrets to clean, limitless energy, a technology that could end our reliance on fossil fuels and lift billions out of poverty. It could contain the physics of faster-than-light travel, a key that could unlock the stars and transform us into a truly interstellar species. It could contain the very nature of consciousness, a final, profound answer to the question of what we are. It could be the cure for aging, for disease, for death itself. It could be the greatest gift ever given, or it could be a warning about some cosmic danger we are approaching, a warning about some self-destructive tendency inherent in all young, intelligent life, or, most chillingly, a warning about the senders themselves. The library could be a lure, a Trojan horse, its contents designed to lead us down a path of technological development that would ultimately enslave or destroy us. We do not know. We cannot know. Not yet. All we know is that the silence of space was never empty. It was full of patience. It was waiting for us to develop the senses to hear, the intelligence to understand, and perhaps the wisdom to choose our next words carefully. Our journey ends here, for now, with this new and terrible knowledge. We have been demoted, but we have also been invited. We have learned that we are not the first and that we are not alone. The universe is not a silent void, but a library, and we have just found the key to the front door. The final question, the question that will hang over the future of our species for generations to come, is a simple one. Now that we know the library exists, do we dare to read the books? And are we prepared, truly prepared, for what we might learn about ourselves, about the true nature of the cosmos, and about the responsibilities that come with knowledge? The age of radio SETI, the age of shouting into the darkness and hoping for a reply, is over. The age of gravitational listening, the age of sitting silently, patiently, and humbly, has just begun. The universe has spoken. And now, for the first time in our history, we are finally learning how to listen.